Hey guys, welcome to eMaths. Let's do some maths for fun. Today, we are going to talk about Gauss-Jordan Elimination. In previous video, we have covered Gaussian Elimination, which is the origin of substitution and elimination method when we solve linear system. Today, we will extend from there with Gauss-Jordan Elimination. When we use Gaussian Elimination, we convert the system into augmented matrix form and perform row equivalent operations to obtain row echelon form. The question is, what exactly is row echelon form? To be in row echelon form, a matrix must have the following properties. For now, we just focus on the number before the separator. Number 1, the first non-zero element in the row is 1. For example, we can have this, or this. If we ignore the zeros, 1 just looks like the leader in the row, right? So we call them leading one. But there is an exception for a whole row of zeros. Number 2, all elements below leading one is 0. In other words, leading one is not only the leader of their own row, but also steps on zeros from other rows. Very bad how this leader.
ぶっちゃけ勝てる自信あるよね。少々の犠牲は出すかもしれないけどさ。
うちのリーダーはその少々の犠牲を嫌うタイプなんですよ。ハンデを背負って D ゲームをしているようなものです。
Number 3. Row consisting entirely of zeros are at the bottom of matrix. That's the general properties of row echelon form. If a fourth property is also satisfied, a matrix is said to be in reduced row echelon form. The fourth property is each column that contains a leading one has zeros elsewhere. You see, this is what happens when you are a bad leader. Just kidding. As you can see, we have zeros above and below all the leading one. With that, we can directly read the solution in this form. Okay, let's get into the topic. Are you ready? Start off. In demo round from previous video, we have obtained the matrix in row echelon form. Our goal today is reduce echelon form. All we have to do is continue to perform row equivalent operations. To get the 0 here, since the third row has its leading one in third column and nothing in front, we can just multiply it by 10 over 9. Then add it to second row. 10 over 9 plus negative 10 over 9 is 0. Write this into the matrix. To get the 0 here, same thing, multiply third row by negative 3. Then add to first row. Negative 3 plus 3 is 0. Write this into the matrix. Almost done. I need some space here. To get the 0 here, multiply second row with negative 2. Add it to first row. Write this into the matrix. And we are done. I have some tips for you. To make a number maybe n into 0, let's say n is here. Step 1. Locate the leading one from the same column. Step 2. Multiply that row by negative of n. The reason here is, well, 1 times any number will equals to the number itself. This will make our life easier. Step 3. Add it to the original row containing n. You see, with this technique, we can guarantee to get the 0 that we want. This is very important because it determines which row we choose. Simple, right? Here's another strategy. We should always do from bottom to top. This part is quite different from Gaussian elimination, right? But the idea is actually the same. The key idea is we only consider leading one. When we perform Gaussian elimination, the main reason that we start from top is to save trouble. Once we get the leading one here, we can get this 0 easily by just multiply first row by the negative of the original number and add it to second row. Similarly, once we obtain leading one here, this 0 will be very easy to get. This explains why the best way to do Gaussian elimination is to start from top. But if you observe carefully, when we reflect this part across the diagonal of the matrix, we will get reduced row-echelon form. Still not convinced? Well, now I will reflect the error as well. This explains why for Gauss-Jordan elimination, we do from bottom to top to obtain reduced row-echelon form. Example 2. In the last video, we have converted into row-echelon form, so we will continue from here. Do from below to top, so we will start here. Our goal is reduced echelon form. Leading one in the same column is from row 3. New row 2 will be positive 7/5 times row 3 plus original row 2. To do it fast, we are very sure that we will get a 0 here. We just have to calculate positive 7/5 times negative 2 plus 34/5 equals to 4. Next target is here. New row 1 equals to negative 5 times row 3 plus row 1. Confirm we get a 0 here. We just need negative 5 times negative 2 plus negative 17 equals to negative 7. Our last target is in this column, so we need leading one from row 2. New row 1 equals to positive 2 times row 2 plus row 1. We know we will get a 0 here. Positive 2 times 4 plus negative 7 equals to 1. And that's it. That's the answer. Bravo! Example 3. This time we will try to do without matrix notation. See what will happen. We actually did this question in last video. That's where we derived elimination method from Gaussian elimination. Anyway, let's do it again. Let them be equation 1, 2, and 3. First two equations already in row echelon form. Don't touch them. Multiply equation 1 by negative 3. Add to equation 3. Let it be equation 4. Multiply equation 2 by positive 4 plus equation 4. Divide by negative 12. Z equals to 45. Draw a line. This is what we have now. I will put the matrix at the side for your reference, but I will not use it. From here, I can straight away tell you y is positive 2 times 45 plus 30 equals to 120. X plus y is negative 1 times 45 plus 180. And x is negative 1 times 120 plus 135, which is 15. Well, in reality, no one will do that to find x. In this case, although we strictly follow the idea of Gauss-Jordan elimination, in fact, we can just play cheat and sub z and y into equation 1 and solve for x. We will still get the same answer. The most important thing is not how many methods we know, it's how we integrate each method into our steps to make our calculation as simple as possible. Finally, we can start to solve the final question from last video. System of linear equations with 4 variables. First step is always convert to augmented matrix. Wow! We have 4 columns of coefficient because we have 4 variables. And we have 4 rows because we have 4 equations. Great. Our first goal is, of course, row echelon form. We will first multiply row 3 by negative 1 and make it into row 1. Original row 1 becomes new row 3, so that I can get my first leading one here. Now, negative 7 times row 1 plus row 2. 1 times negative 7 is negative 7. Negative 7 plus 7 is 0. Maybe we do more at once. Negative 2 times row 1 plus row 3. 1 times negative 2 is negative 2. Negative 2 plus 2 is 0. Then negative 3 times row 1 plus row 4. 1 times negative 3 is negative 3. Negative 3 plus 3 is 0. With that, we are done with all the zeros in first column. Continue. Divide row 2 by 16. We get our second leading one. Next, negative row 2 plus row 3. And negative 13 row 2 plus row 4. Okay, I know these fractions are very scary, but we have just obtained all the zeros in second column. To make our life easy, I will convert them into decimal form for the moment. Continue. Divide row 3 by negative 5.875. We got the leading one in third row. Take negative 13.625 times row 3 plus row 4. We got the last zero we need. Multiply row 4 by 47 over 68. And we got the last leading one. Row echelon form done. But this is not the end. Part 2. Reduce row echelon form. We all agree that starting from now we should do from below to top. Let's start. Negative 17 over 47 times row 4 plus row 3. Use the shortcut from earlier. Put a 0 here. We just calculate negative 17 over 47 times 4 plus negative 261 over 47. Same denominator, very easy to calculate. Equals to negative 7. Next, 0.875 times row 4 plus original row 2 and 3.125 times row 3 plus the new row 2. I write as row 2 prime. Combine them together, 2 in 1 faster. Then what about the constant? Don't worry, just take 0.875 times 4 plus 3.125 times negative 7, then plus with 18.375. Equals to, unfortunately, 0. Last but not least, negative 2 times row 4 plus original row 1. Negative 7 times row 3 plus row 1 prime. Positive 2 row 2 plus row 1 double prime. Combine them together, 3 in 1. Negative 2 times 4 minus 7 times negative 7 plus 2 times 0 plus negative 46 equals to negative 5. From that reduced row echelon form, we can directly read the solutions. And that's the answer! Alright, that's all for today's video. For the next video, we will do a comparison between Gaussian and Gauss-Jordan elimination. If you like this series, see you guys in the next video.